Hello? Yes, so we're going to continue. On the program we have said that it was first question and answer and then panel, but because of time we only do questions and answers, because I think my expectation is, or our expectation is, that it's with questions and answers we will fill up the whole time. And I have already the first question for Don about from the streaming. The question is from Daniel Kilpatrick, and his question is, it's a few questions in the same. If our difficulty is looking at reality, that we see everything through a lens that describes everything in separate things, is this our conditioned perspective? Does this say something about reality? And then he continues, if consciousness is the ground of everything instead of materialism, can a perspective that assumes everything is separate capture it? Or must we start with our thought-based separative perspective?
Right. There's an interesting technical question that I'll have to solve. We're going to have to start with this network of conscious agents, look at its properties, understand its as a dynamical system. One thing that comes out of the mathematics there is that although you can think of this network of conscious agents as an infinite set of different agents, because anytime two agents interact, they become a single agent. The whole thing is also a single agent. So there's this very interesting mathematical structure here that is one, and yet it can also be viewed in its parts, but the parts are all one. And so I want to explore that. The notion of free will that comes out of this also has the same property, that you can look free will locally of each agent, but there's also the free will of the one, and it can be dynamically understood in terms of all the free wills of the parts and how they interact. It's going to be a complex dynamical thing. But now to get to the question about, we see in our interface a world of different objects that look separate. And how much can we infer about objective reality from that? And there are two key aspects of it. First, I'll just talk from the point of view of evolution by natural selection. So just forget the realm of conscious agents for a moment. Just think about evolutionary biology. From an evolutionary point of view, it's the fitness payoff functions that are critical. Our perceptions have been tuned to those fitness payoffs. And so the objects that we see, we usually think of objects as our estimate of the true physical objects that have the shapes and colors that we see. We think that we're recovering close approximations to the truth. Evolution by natural selection, just by itself, forget all the consciousness stuff, just by itself says that's the wrong framework. Think of objects as solutions to an adaptive problem. The adaptive problem is this. You have many different fitness payoff functions that are governing your survival. Fitness payoffs having to do with actions like eating, the famous 4Fs, feeding, fighting, eating, and mating, and so forth. There are all those fitness functions that depend on the organism, its state, and its action. There's a lot. If you forget reality, just look at the fitness payoff functions. There's an overwhelming amount of information in the fitness payoff functions that's critical to your survival. We have to data compress that. So, forget about reality. We even have to data compress the fitness payoffs. And physical objects are a satisficing solution. Good enough, but not perfect. That's what I mean by satisficing. It's good enough, but not perfect. A satisficing solution to the problem of representing fitness payoffs in an actionable format. Just enough about fitness to keep me alive, not everything about fitness. So the reason, from an evolutionary point of view, why we see a world articulated into objects is that turns out to be a nice data compressing, error correcting code for fitness payoffs. No one is thinking about physical objects that way. No one. I propose, if you like none of the consciousness stuff, you just want to walk away from it, you still want to be a physicalist, and you just want to look at evolution by natural selection and fitness payoffs, this is still an interesting problem. Physical objects not as representations of the truth, but as satisficing solutions to a computational problem of representing fitness payoffs. So my guess is that we will see that the articulation that we perceive of a world with separate physical objects is going to be explained as a satisficing solution to the problem of representing fitness payoffs. And that will be an actual, probably mathematical theorem, that this is, in some sense, an excellent way of doing that. Now, going back now to the consciousness stuff, there's another level to answer that question, which I'm very interested to do as well. And it has two parts. First, if the objective reality is a dynamical network of conscious agents, and space and time and physical objects are a visualization tool, I want to understand, evolution by natural selection is a wonderfully powerful theory in our interface. It's a theory in space and time. It's about evolution in space and time. It's not a theory in the realm of conscious agents. There's some deeper dynamics going on in the realm of conscious agents. That deeper dynamics, when we project it into our interface, it looks to us like evolution by natural selection in space and time. So I'm very excited to try to understand what is the dynamics of conscious agents that when we project it into our particular Homo sapiens specific interface, it looks like evolution by natural selection. I may not be smart enough to do that. And so what I'm hoping, and I'm actually betting against myself on that one. So what I'm hoping to do is, if I can get the mapping from the conscious agent network dynamics into space-time, and we do have proposals about that using geometric algebra. For those who are interested, I'll just put out one technical thing. I'm using a geometric algebra of signature 2,4 as the projection from conscious agent networks into our space-time. It gives us supersymmetric and formal field theory. End of the nerd stuff. So that's the direction I'm looking at. What I'm hoping to do is to be able to pull back evolution by natural selection. I have a map from conscious agent networks into space-time. Can I take evolution by natural selection in space-time, pull it back, and ask what it would look like in the conscious agent dynamics? That might help me to understand what are the principles going on in this realm of consciousness. Because, there's a big question. What is consciousness about? What is it for? As a scientist, why is there a dynamics? What is the dynamics about? For example, is it about conscious agents trying to understand each other? Technically, is it about conscious agents that at first don't know anything about each other, trying to maximize their mutual information, where mutual information is a technical term, but it actually makes sense informally. If I'm trying to get mutual information with you, we're trying to understand each other, but technically it could actually be a dynamical system in which each agent is acting so as to maximize the mutual information with other agents. Is that what's going on? I'm going to be probably pursuing that hypothesis, but I don't know. And so what we're going to, that's the nice thing in science. You don't know. It's a wild exploration. We'll try that dynamics. If when we project it into space-time, we get something like evolution by natural selection coming out, that won't mean that we're right, but it'll mean that we might, that it might be a good direction to pursue. So the question is great because it's touching on where we're going next in all of this. There's a lot of technical work to do, and that's the nice thing of having a mathematical theory is I'm not just saying consciousness is fundamental. There are specific. I could have a team of dozens of mathematicians, and I could give them all problems today that would keep them for the rest of their lives. There are hard technical problems to solve here. We can launch a new field. So this is not just philosophy, and I love philosophy. I have a joint appointment in philosophy, so there's nothing against philosophy. But this is different. We're actually trying to build mathematically precise models and get somewhere with a scientific theory. So, great question.
1, 2, 3, 4.
Yeah, thanks, Don. Lots of questions, but I'll just start with something simple, which is to do with terminology. So the title of your presentation was Perception, Illusion and Truth. And so the word perception, you obviously used it in the way it's used in cognitive science, which is a processing of information, typically sensory information. So the receipt of the sensory information precedes any kind of perception. There's no perception without information. And in many Krishnamurti circles, he's used that word perception, or when, as you know from yesterday's discussions, some sort of like direct looking,
Right.
you know, without a filter, perhaps even without that of the limitations imposed by senses. So you might want to clarify that. And then the second...
Okay. Maybe I should start with that, so I don't forget.
No, let me ask the second one, then you can go with both. And the because
I'll try to remember both.
It's a terminology issue. I'm curious why you use the word conscious in all your work, or consciousness, because as you know, your use of the word conscious with reference to conscious agents and consciousness is quite different from how it's used traditionally, as in I am conscious of, I am aware of, where it's an I that is conscious. You're using it very differently from that.
Right.
And you're using it very differently from how it's used in, at least to the best of my understanding, traditional spiritual circles.
Sure.
That there's some consciousness that pervades and acts and, you know, all
Right.
the rest of that stuff. So you might want to clarify those two things.
Thank you.
And tell us in what way you're using these terms before we, you know.
So there's the question of information, the question of direct perception, and the question of the use of the word consciousness. I'll start with direct perception. I would say the vast majority of my colleagues in cognitive neuroscience and in also, you know, computer vision and computer perception take perception not to be direct. They view it as a process of inference. That in some sense, in the case of vision, you have photons hitting the retina, have 130 million photoreceptors, and those are the basic premises, and then you have Bayesian inferencing processes that lead to perception of the physical world and objects in space-time as a reasonable conclusion based on certain assumptions that are built into us. So most of my colleagues do not think that perception is direct. They think it's indirect in the sense that we're building representations. But there are many in the embodied and radical embodied cognitive science tradition who disagree. And they say that perception is direct. Anthony Chimero, for example, is one. And they don't say that we represent the world, rather that our perceptions present the world. It's a direct perception. And that has taken hold in some circles. It's a minority view, and I think it's wrong. I mean, I think that it has some serious problems. When we have an illusion, are we directly misperceiving? And what does it even mean to directly misperceive? There are issues with it. So I would just say, you know, that's now an interesting, you know, inside baseball kind of thing among scientists about the direct versus indirect perception. And right now, I would say that the majority think inferential perception is the standard. Now, on the notion of information, information as it's standardly used is viewed almost as an objective thing. Like physical systems can have information and they can process information independent of whether anybody observes them. Right? That's sort of the standard view. And of course, I can't take that view, right? Because physical systems like computers don't even exist when they're not perceived. So what's going on with information processing? And it comes down to, we have to look very carefully at what we mean by information. It turns out the technical definition, the Shannon information definition, is, I'll just state it, but then I'll give the intuition. It's minus log probability. So if you have an event that could happen, like I flip a coin, about heads or tails, the probability is a half. You can take you can ask, what is the information that I get from flipping that coin? And it's related to the probabilities of the outcomes. If it's 50-50, and you get one bit of information. If the probability is 1, that it's going to come up heads, then when you get heads, there's no information, there's 0 bits. So the key point is that information and probability are the same thing. There's just a minus log transform between them. But they're the same thing. So the question of what do we mean by information comes down to what do we mean by probability? And there are two big theories about probability. There's the subjectivists and the objectivists. The objectivists say that probabilities are statements about true objective probabilities in space, objective chance. Occurrences. So there's this notion of objective chance. And probabilities, you can, for example, count them out by looking at frequencies of events that you measure in space. So there's the objectivists. Then there's the subjectivists, which say that probabilities are nothing but degrees of belief. What is my probability that I assign to flipping of the coin? Well, it's my guess about what I expect to happen. And so there's been a long debate for centuries between these two. And I'm clearly in the camp of the subjectivists. I'm saying that probabilities are degrees of belief. They're not objective chances in a pre-existing physicalist world. Because I'm rejecting that pre-existing physicalist world. I should mention there's one other notion of probability, that there could be a deterministic world and we have partial knowledge of it. So it's an epistemic probability. But in terms of where we say probability is really telling us something about reality, not about our knowledge of reality, there's the epistemic versus subjective. So I take a subjective view of probability and therefore a subjective view of information. The only information is information being processed in the minds of conscious agents. Now, the word consciousness. First, I should just say exactly what I mean. By consciousness, I'm talking about specific conscious experiences. Taste of chocolate, smell of garlic, and so forth. That's what I'm talking about when I say consciousness. Most of my colleagues in cognitive neuroscience who are looking at the hard problem of consciousness, and that's the phrase we use, the hard problem of consciousness. So it's within that field, we're using consciousness in two senses. We're using it in the sense I just gave, the hard problem of giving a theory of specific conscious experiences like the taste of chocolate, and also just the notion of experience, consciousness in terms of an on-off switch. Like when you go into deep sleep and there's no dreams. In some sense, there's an off switch that's gone on, and there's so there's just having any awareness at all versus none. So we want a theory of, we talk about consciousness in that sense, and then we also talk about consciousness in the sense of specific conscious experiences. And so we have those two kinds of hard problems that we're trying to solve. We will also talk about higher levels of consciousness in terms of like self-awareness, conscious of being conscious. And normally we don't even talk about that when we're talking about the hard problem of consciousness, because it's already hard when you just deal with raw experiences themselves. It's already hard enough, the problems are right there. But so what we might do is talk about self-consciousness and be explicit about that. And then, when we get to spiritual traditions, we're talking about, then we're thinking about maybe, really all sorts of other higher, very, very high forms of consciousness beyond even human experience. And when I talk about the theory of conscious agents, and that there could be agents of which I'm a part, but that are in some sense higher than me, I'm just part of their instantiation, I'm then using a framework that allows me to talk about higher levels of consciousness that are way beyond anything that I perhaps can ever conceive. So I'm using consciousness in a way that can be booted up to try to give rigor to the notion of consciousness as is in spiritual circles as well.
Conceptually, I found your talk quite fascinating, because you seem to be reversing the whole belief in science that space-time originated with the Big Bang,
Right.
and then the subsequent development of the universe, and then the origin of life, and then the origin of consciousness or self-consciousness. The difficulty, as I see it, would be that if you start at the end of consciousness, the scientific method requires you to build models, apply logic and mathematics and so on, make predictions,
Yes.
which are verifiable experimentally. Now, consciousness phenomena are not easy to measure. And that has been in my opinion, the hard problem of consciousness as studied by scientific methods. Because most of the things in consciousness are not yet measurable, and even whether there is such a thing as consciousness is doubted by many scientists. So how do you expect to get around that problem? Because without that, they won't accept it in science.
Right. Good question. There are two fundamentally different attitudes you can take. One is to say, look, I know that there are physical, you can bang on them, everybody sees them, you see the same table, and so forth. And this is the real stuff, and we can build science on this. We have, objective measurements, and we all measure the same thing. And that's what science is built on. That's one outlook. Here's another outlook. It's quite possible that everything that I think I know is false. It's quite possible that I know nothing. But if I know anything, if I'm right about anything, it's that I have conscious experiences. If I'm wrong in my claim that I'm actually experiencing sounds, feeling pressure on my hand, if I'm wrong about that, then I'm wrong about everything. And you might as well just have a beer and enjoy life. There's two different, and from this point of view, I could be wrong about having a white rectangular experience. And if I'm wrong about that, then it's game over. But suppose I'm right about that. It's a further claim, and an interesting claim, that people say, well, you know what? Not only are you having that experience, but in addition, it's also true that in objective reality, there is some object that actually has the same rectangular shape and color and so forth. I go, well, wait a minute. I'm willing to grant that I have the conscious experience. I'm willing to grant that. But you're making an incredible leap beyond. The whole idea about this physical world existing independent of my senses and resemblance, that's an incredible leap. What in the world justifies that? I'm having a hard enough time just maybe granting that I have the experiences. So the physicalists always come off as, of course, we're making the minimal assumptions. Absolutely not. They're not making the minimal assumptions. They're making a really strong assumption. I'm willing to grant that I have conscious experiences. The idea that you see exactly the same thing as me, all bets are off. With synesthesia, we know all bets are off. So the physicalist is, it always seems like, of course, we're going to be being hard-nosed, we're not making any assumptions. That's making huge assumptions. Making the assumption that our perceptions reconstruct reality. I'm just proposing that we construct our perception, that we construct, not that we reconstruct. So that's one aspect of it. Another aspect is, if this framework is right, science so far has done nothing but study conscious experiences. Space-time and physical objects are just the forms of our experiences. And that, I think, is what quantum mechanics is trying to tell us with the measurement problem in quantum mechanics. Guys, your assumption that you're dealing with an objective reality that exists independent of you is just wrong. And that's what quantum mechanics is telling us. And we're going to have to deal with that. To solve the measurement problem in quantum mechanics, we're going to have to actually go to this framework in which we don't just talk about the observer but then ignore it. The quantum physicists will not define an observer. They will not do that. apparently, that's what it's all about. We have to define observers, and it's the interaction of networks of observers that gives us back what we call, as a framework of, visualization framework, space, time, and matter. A third aspect of this. Science is about being precise in your hypotheses and then saying things that you can test. It's actually not about verification. We can't really verify anything in science, right? That was a point that Karl Popper made, a very famous philosopher of science in the 20th century. That science, there's this problem in the philosophy of science about what they call the demarcation problem. What makes scientific approaches to knowledge different from other approaches, and hopefully superior, right? And it's turned out to be very, very difficult to solve the demarcation problem. So Karl Popper proposed, we can't verify our scientific theories, but maybe scientific theories are distinct from other forms of knowledge in that they can be falsified, that you can actually make predictions that are falsifiable. And most scientists take Popper as, that's a good idea. And most of us informally think that's a good idea. We want to be falsifiable. We can't verify, you can't ever prove any scientific theory to be true, but you can try to falsify it. So and I do take that as good practical science. Make a prediction that someone can go out there and make an experiment and test. And so here's, in my case, clean prediction. Local realism is false. The assumption that physical objects have definite values of position, momentum, and spin, even when they're not observed, and that those values of position, momentum, and spin have causal effects that propagate through space-time at no faster than the speed of light, that's local realism. Clean prediction from my theory, that's false. Another one is that non-contextual realism is false, that, again, objects have properties like position, momentum, and spin when they're not observed, and that the values of those properties do not depend on how you choose to measure them. That's the non-contextual part of it. So I predict that local realism is false, non-contextual realism is false. It's a clean prediction. You might say, well, look, you're predicting, I'm saying this table doesn't exist when no one observes. How can you test that, Don? You're talking about what happens when no one observes. That's a pretty low bar of experiment. How are we going to test that? You're saying the table doesn't exist when no one observes it? How can you verify that? That's dumb. That's not even a scientific. Well, it turns out that question came up in quantum mechanics. Do positions, momenta, and spin exist when they're not observed? And Einstein was worried about that. He was saying, this is an important question. I think quantum mechanics is incomplete. There are hidden variables that we need to get that goes out. And Wolfgang Pauli said, Einstein, this is silly. This is like asking how many angels can dance on the head of a pin. Who cares? We could never answer the question about does an electron have a position when no one observes it. So why are you even worried about that, Einstein? And then in 1963, John Bell discovered that it's not a question like how many angels can dance on the head of a pin. It's a real question. We can actually answer that question. He gave a quantum experiment and the mathematics for the local realism, and then the next year he showed how we could test non-contextual realism. And I won't go into the details, but you can test with real experiments the claim that doesn't have a property like position when it's not observed. It sounds impossible. It's one of the deepest intellectual triumphs of human history, John Bell's discovery. It's non-trivial, and we can do that. And we've done the experiment many, many times. We've repeated it because local realism fails every time. And people bang their head, that can't be. There must be some loophole. And so someone proposed a loophole in the experiment, and we keep closing the loophole. So it's a clean prediction of my theory that local realism, non-contextual realism are false. Those are testable hypotheses, and so far, my prediction has been upheld. Yeah, that's the measurement problem in quantum theory, right? Right.
No, how to build a theory, you will need to make predictions and then make measurements. How do you make measurements in consciousness?
All of the experiments that we've ever done in physics are measurements in consciousness. Everything that we've done. Space-time itself is nothing but a conscious structure. But there is another field, I'll talk about just briefly another field. There's the field of psychophysics that I've also been a part of. And in psychophysics, psychophysicists are psychologists who get people into the lab and make careful measurements of their perceptual experiences. And we build mathematical models like of color space. I showed you that the rotating dot kind of thing. We can actually make measurements, psychophysical measurements of the conscious experience of the depths that you have, and see how much depth you're experiencing, and then check it against our mathematical models. So psychophysics is actually a branch of science that's been around since a guy named Fechner, 1870 or something like that, sort of founded the field. So it's been around for 150 years. And we do careful experiments on human experiences, we build mathematical models, and so there's genuine science there. And most of my colleagues would say, yeah, clearly we have a experimental science of consciousness because we have psychophysics. And they would stop there, and I'll go there, but then I'll say, every experiment that we've done so far has been an experiment on consciousness. We've never ever studied anything else because that's the nature of reality. Yeah.
I am, because thank you for that talk. It's quite fascinating, the whole thing. When you've been talking about consciousness, as we just were, what I hear you saying, and maybe it's a misapprehension, we're talking about human consciousness, which is largely thought. Have you anything to say about consciousness as it is manifested in plants, in animals, even rocks? In what way do they fit into or are a part of this whole field that you're exploring and have been talking to us about?
Great question. So the conscious agent theory of consciousness that I presented is proposed to be completely general. Completely general. There is no aspect of consciousness, general, completely general. The claim, and it's a fallible claim, I could be wrong, but it's a bold claim, that framework the mathematical framework that I described can, in principle and in practice, mathematically model any consciousness in the universe of any type. So now the question is, what about plant consciousness and so forth? And there we have to be very, very careful because of assumptions we bring to a question like that. We're all physicalists at heart. We all deeply believe that this stuff exists independent of us, that we're seeing it as it is, and Piaget told us when this happened to us. We get what he called object permanence. He figured it was around 18 months that we have this genetically pre-programmed belief in the pre-existing nature of objects. And you have a doll, and before 18 months, the kid looks at the doll when it's visible. If you stick it behind a pillow, it ignores it. It's gone. But at 18 months, even though it can't see the doll, because you put it behind a pillow while the kid is watching, at 18 months, the kid will go try to grab it. It now knows that even though it doesn't see the object really exists. And so we get this. Then Gordon Bauer and others have found that maybe it's as early as 3 or 4 months that we get this object permanence. So that's what I mean when I say we're wired up to be physicalists. We assume that space-time and matter exist and physical objects exist independent of us. So when we talk about plant consciousness, most of us, the way we're thinking about it is there are these physical objects that exist independent of us called plants. And the question is, are they complicated? They don't have neurons, but they do have cellular processes. Is there in some sense in which they're processes are complicated enough that consciousness might somehow emerge in the plants. That's sort of the way we tend to think about it. My framework is utterly different, right? Strictly speaking, when I'm interacting with you, the body that I see is not conscious. The body that I see is my symbol in my interface. And that symbol, strictly speaking, is not itself conscious. It's an experience that I, as a conscious agent, am having. So your body that I'm seeing is my conscious experience, but being a conscious experience does not make the symbol itself conscious, right? But the symbol that I'm experiencing with the blue sweater and blue pants and glasses and so forth, that's my symbol, and that symbol is not conscious, strictly speaking, as my experience. But I believe that my symbol is a portal to genuine consciousness of someone who calls himself Stan. And there's a whole world of conscious experiences behind that symbol that I'm interacting with. But the symbol itself is not conscious. It's my conscious experience. So the question is now with the plant. The symbol, again, the plant itself, is not conscious. It's my conscious experience. And the question is, what's on the other side of my symbol? Now, under the conscious realism hypothesis that the universe consists of just this vast network of conscious agents, what's on the other side of any symbol, including this inert podium, is the realm of conscious agents. I'm not saying that, so this is not panpsychism. Panpsychism is the doctrine that physical objects really exist, at least one version of panpsychism. It's subtle, but here's this one version of panpsychism. Physical objects really exist, like an electron really exists, and in addition to its physical properties, it also has a unit of consciousness. And a proton is a physical property, but it also has a unit of consciousness. And when the proton and the neutron get together, they form a hydrogen atom, which has a new consciousness, which is somehow the combination of the two consciousnesses. That's more of like a dualist view, although I have good friends who are panpsychists who say, no, Don, it's not dualism. And they've never been able to convince me. But anyway, I'm not a panpsychist. I'm not saying that this table exists and also has consciousness. And I'm not saying that a plant, like a mustard plant, exists and also has consciousness. That's not what I'm saying at all. I'm saying the mustard plant is a data structure that I create. And I experience that data structure as a conscious experience. That's the best that I can come up with as I'm interacting with this vast realm of conscious agents. If it doesn't give me much insight into the vast realm of conscious agents, it's not because there's no consciousness out there, it's because I've given up. So in some sense, everything that I see is my symbol that I create as a result of interacting with other conscious agents. Some of my symbols give me very good information, like when I'm interacting with a symbol that I call Stan. And some no information, like the podium symbol. I'm not saying that plants are conscious, just like I'm not saying that the human body that I see is conscious. Strictly speaking, is not. But I think that I am interacting with conscious agents, but I'm getting very, very little insight into them. But we do get these really interesting hints about plants. Trees share carbon. They help each other. Different species of trees will actually help each other at different seasons. And trees can actually recognize their offspring and will preferentially help their offspring. There's things going on in plants that look really, really interesting. But I'll leave it at that. Okay.
Thank you. And the speaker shared the discover from the ordinary phenomenon sensitively. Thank you. But we still don't know anything about unknown. What's the unknown? That's the question.
About what?
Unknown.
Unknown. Okay.
And all of us exploring, and just like a telegraph can arrive event horizon, like a telegraph do for the black hole. But we still don't know anything about unknown. Maybe scientists like use the special word dark energy to name the unknown. But we still living in it. And all of us here, happened here. Body and thinking, all of us, activity to like to continue living across the living moment. The living moment be escaped or covered by us. So question is how can we freedom? Is it possible freedom from no?
Okay, good question. Yeah, Krishnamurti talks about freedom from the known, and how does that fit into the framework that I'm talking about? Here's one possibility. That could be fun for discussion. What is the known? It's a virtual reality. We all have a headset on. It's our visualization tool. But the human condition, standardly, is to not recognize that this is just a virtual reality. To be so hooked in to the simulation that we think it's all there is. That's what physicalism is. Physicalism is the assumption that this is the final reality. What this framework, this scientific framework gives us is the realization that we've always had a headset on. And maybe what Krishnamurti is talking about when he says that you can just sort of see through it in a moment. It's just realizing, oh, this is just a headset. It gives you a completely different perspective. I'm not a bit player on the pre-existing stage of space-time. I'm the author of space-time. And that is a fundamental shift. It's a shift to saying, this isn't, I'm not seeing, what I call the known isn't the truth. This is just my headset. This is my virtual reality. There's something infinitely more interesting and complicated beyond it. I'm proposing it's the network of conscious agents. That is the unknown, and it's unknown in the following sense. You might say, well, you're building a mathematical model of it. How could you say it's unknown? We did the little experiment, imagine a simple color, a single color that you've never experienced before, right? Imagine it concretely. You can't do it. I'm modeling an infinite number of agents with an infinite variety of conscious experiences, none of which I can know. I can't even know a single color experientially that I've never experienced. I just can't do that. But as a mathematician, as a scientist, I can, fortunately, use the power of mathematics to describe these worlds that I can never experience. So it's unknown to me, I can never experience it, and yet, as a mathematician and scientist, I can begin to try to model it. So we can hopefully have a cake and eat it too, recognize that it's unknown, but have some idea what it is that we don't know. And that's sort of the goal. That would be, I think that's the starting point of a dialogue. Is that a reasonable way of thinking about what Krishnamurti is talking about when he says letting go of the unknown? Is it? This is a VR. We can take, it is a headset. We can imagine what it's like to take the headset off. Maybe in practice, most of us can't just take the head. I mean, what does it mean to even take the headset off? What would we be experiencing? That's an interesting question. But maybe it's just the recognition that this is a headset. And losing the addiction to the headset is the critical step.
Thank you, fascinating talk. I was going to ask about the falsifiability question that the gentleman asked earlier, but I'm going to ask you a little bit different question, which is on the second part of your theory, where you mentioned that you wanted to derive the rest of the laws from the starting with the very basic basic formulation about the conscious agents.
Yes.
Now, my question is, how do you square away with the incompleteness theorem, which has its own basic limitations, where you cannot formally prove the completeness of the theorem itself?
Right. There's two incompleteness results that I think are interesting. One is Gödel's, that any system of mathematics that's complex enough to do arithmetic, there are unprovable truths within that system, and you can prove that there are unprovable truths. You can show them. so that what it tells us is that the notion of truth is, in some sense, goes beyond the notion of proof, which is interesting, right? So that means my hope with mathematics can only take me so far, right? Mathematics is not the infinitely powerful tool that we might have hoped. They're unprovable. Of course, you can always add the new theorem as one of your premises and get a more powerful system, so you can always get more and more powerful. So yeah, there are fundamental limits to what we can do with math. So the way I think about math is it's a tool of precision, and is a way for us not to fool ourselves, not to BS ourselves. It's a way to be absolutely precise, put our hypotheses on the table so others can really test them. And also so that, excuse me, so that we actually see what the implications of our ideas are. The mathematics lets us do that. And I'll just give you one really fun example. Einstein had an idea about gravity, like 1907, that maybe if you're in an elevator and the elevator is sitting here on the Earth and we're inside the elevator, you can't look outside, you feel yourself pressed to the bottom of the elevator because of gravity on Earth. Then he said, imagine the elevator's out in space, away from any planet, but you have a rocket pushing on it with 1g force, and you're in the elevator. It's going to feel exactly the same. Einstein said that was his happiest idea of his life, was that idea. That was the founding idea for general relativity. But it took him the better part of 10 years to take that idea and write down a one-line mathematical equation, which is the equation of general relativity. It took him a long time. The idea by itself was a great idea. We can talk about it over beer, have a good time. Oh, neat idea, Einstein, really neat. And it would go no further. But he took the extra time, 8 to 10 years, worked his tail off, agony, for working in despair, coming up with equations, didn't work, until he finally got the equation of general relativity. And that then captured his intuition. And then all of a sudden the equation becomes smarter than the person who writes it down. A year after he published it, Schwarzschild, some German guy out in the trenches in World War I, he was playing with his equation. It's hard to imagine, bombs going off and so he's playing with the equation. He finds a solution that leads to black holes. Amazing. Einstein didn't even think you could get a closed form solution to his equations. He thought you'd just have to run, And so Schwarzschild sends him the paper, and Einstein is blown away. He's impressed by the mathematics is real, the guy's done it. But Einstein did not believe in black holes pretty much the rest of his life. We just saw pictures of them, of one. There's a black hole 55 million light years away from us. We just saw a picture of it. Einstein's theory was smarter than Einstein. And that's why we do mathematics. So there are limits. There is the Gödel's incompleteness theorem. It can't do everything, but boy, it can sure do a lot, and it can be smarter than Einstein. I'm on board. There's another aspect to it, and that is there's another kind of incompleteness. No finite system can ever completely model itself. Because in the very process of modeling yourself, you become more complicated. And so now you're going to need more resources to model yourself, having modeled yourself. And you get in an infinite loop. And I'm wondering, when I ask, what is the dynamics of consciousness all about? And I don't know. I'm trying to find some fundamental dynamical principle. Could it be that consciousness trying to understand itself is the principle? And because no finite system can ever completely understand itself, the dynamics is forever. I don't know. But that's the kind of hypothesis that I'm trying to explore.
Thank you.
I think he's got the mic. You'll have to get his attention.
I wonder if you could talk a little bit about one of the miracles that you mentioned in your conscious realism. I'm particularly interested in the selection of a conscious agent and how that differs from another icon or conceptual abstraction that we might make of anything else that we see in reality. And if it is, does it have causal power? And so I'm looking at both the agent and the causation as those miracles, and a little bit more, if you could explain how you selected those and why those don't fall into the category that I've talked about.
Very good. Great question. So I'm not a solipsist. A solipsist says that all that exists is me and my perceptions, and there's no objective reality independent of me. Solipsism may be true, but I'm not a solipsist. And solipsism, as it turns out, even if it seems implausible, it turns out you can't disprove solipsism, right? It's on the table. It's a viable abstract possibility. But most scientists, myself included, are realists. We think that there is some objective reality out there that exists independent of whether I perceive it. And so I'm a realist in that sense. And I'm a realist about consciousness. I'm a realist in the following sense. I have life insurance. I'm betting that my wife is conscious and that her consciousness will persist even after I die. I'm being a realist about consciousness. And most of us have life insurance. So most of us are betting money that realism is true, some form of realism. So I'm proposing, because partly the hard problem of consciousness cannot be solved from a physicalist framework. We've failed to do it, and I think it's in principle. I'm proposing that there is an objective reality, and it is consciousness. And that's the first proposal. The second proposal is then, I want to go beyond just a hand wave and just use the word consciousness. I want to have a scientific theory. And so I propose the mathematics of conscious agents, but with this proviso. The mathematics is not the territory. The math is just the math. Consciousness is whatever it is. Conscious agents are the humble attempt of one scientist to try to put some mathematics on the real reality of consciousness. That's what all science can do. Even if physicalism is true, the mathematics, x, y, z coordinates for space-time, those are just x, y, z coordinates. Space-time is whatever space-time is, right? X, y, z is just x, y, z. So the math is not the territory. On the other hand, so I don't want to mistake my math of conscious agents for the reality. Consciousness will be whatever it is. I'm hoping that my math has captured the essence of it, and if it hasn't, that someone, because I'm being precise, tell me precisely where it's failed. But there is another aspect of this. What is the relationship between mathematics and conscious experiences? And it's, I think, fairly intimate in the following sense. Take a specific conscious experience. Say, and we talked about this last night, a green disk. So I show you on the screen a green disk, and we're all experiencing a green disk. Well, there's an interesting property of your conscious experience. If you look at about the circumference of that disk and then go across it, the ratio of those two things in your experience has the number pi. And if you expand the disk or shrink the disk, you find that your experience always satisfies this really interesting mathematical relationship. And it turns out everywhere we look in conscious experiences, there is mathematical structure. So experience as conscious experience is not divorced from structure. Structure, mathematical structure, seems to be an integral part of conscious experience, but it's not all of conscious experience. There is still what it feels like to see the green disk. But what it feels like involves this structure. So the connection between mathematics and consciousness is really quite intimate. So when I say that consciousness and conscious experiences are fundamental, because of that intimate connection between conscious experience and mathematical structure, I think I'm also really claiming that mathematical structure is part of objective reality as well, because it's an integral part of conscious experience. It's not divorced from it. But when I'm doing scientific theories, it turns out the only thing that I can put in my theories is the structural part, the mathematics, and so that's all we can do. But we always have to be careful to recognize that the math is just the math. It seems to capture some of the structure of the territory, but it doesn't capture all of the territory. It's a great question. Thanks for letting me explain that.
Okay, so we have a question from the stream. And the question is from a man called Robert Stoyilovic. So the question goes as follows. So if everything is conscious experiences, is meditation then some kind of removal of conflict in these experiences?
There are many kinds of meditation, so I'll talk about just the kind that I'm involved in, where I just go into silence. And I'm sure there's many other forms of meditation, and so that's a larger and broader discussion about what we're doing in meditation. But it seems to me that when I just go into silence, what I'm doing is, in some sense, letting go of my addiction to my headset. I'm just, the headset is great for everyday life, but there are times when you just sort of want to let the headset go silent and have nothing go through your head at all. It's actually good for you. It's good health. It's just on physical grounds, physiological grounds, it's very, very healthy. But I think also what I'm experiencing, I should tell you what my personal experience is about this stuff. I'm a physicalist at heart. We're born that way. I believe this. My knee-jerk reaction is, of course this podium exists. Of course it's there when no one's looking. It's, for me, this was entirely an abstract intellectual exercise. I had a technical problem I was trying to solve, and this was the only way I could solve it. So kicking and screaming, I was dragged to the idea that this table doesn't exist when it's not perceived, in spite of every belief that's in my body. So this was not something that I believed ahead of time. But now with meditation, slowly but surely the mathematics is actually more than just mathematics. It's starting to become part of my experience, that this is just a headset. So I can see that the meditation could be a way that we let go of a deeply false assumption that we've made and enter into a deeper kind of reality that this is just a headset, and that there is a realm of conscious agents out there, of consciousness, that we otherwise might ignore or be unaware of. And by the way, the fact that there is all this possibility of stuff that's just not in our interface gets back to something that you mentioned in your question about dark matter. From this point of view, the fact that our interface is just our species-specific headset makes it no surprise that we're discovering that our headset, our space-time interface, we thought it captured everything. Now we realize that dark energy and dark matter are 96% of all the stuff that's out there, and the direction is definitely going against us. It's probably going to be, now we only know 1%, now we know even less than that. So it's no surprise. From an evolutionary point of view and from this point of view, it's no surprise. Our interface is only there from an evolutionary point of view to give us data structures that describe the fitness payoffs we need to stay alive. There's no reason why it needs to give us insights into all of it. We know, for example, that there are like all these cosmic particles that are going through our bodies, millions of them per second, that are eventually going to kill us. But they're not going to kill us before we're grandparents. So there's no reason for evolution to tell us about them. If it kills you after you're a grandparent, then so be it, it'll kill you. But it's things that will kill you today that we have to learn about, that evolution. So it's no surprise from this point of view that there are things like dark matter and dark energy. In fact, most of the universe is dark to our interface. Yeah.
I have one comment and one question. The comment is that some of the perceptions of Krishnamurti support your initial assumption that all the consciousness agents share a common consciousness. And he has not said that from any scientific argumentation or assumption, but he has said that from his direct perception or insight.
Yes.
I don't know what that is. He has said that we all think that we are separate consciousnesses,
Right.
but that's not true. It's the whole of consciousness of humanity is one. Yeah. So all your agents. That was my comment. And the other is a question that we have discussed how our perception of objects and phenomena is partial and causes deception, which is one form of illusion. But there is another form of illusion which is perhaps more sinister than this, and that is to imagine something which is not part of nature and then believe in it and think that that is real. And that has caused a lot of division, because different people can imagine different illusory things and then get attached to their own creations and then have wars about it and things like that.
Yes.
And also there is this religious thing right from the time of the Buddha, saying that all the disorder in our consciousness, which means all the negative emotions that we have in our consciousness, that we experience, originate from some illusion or the other in our mind. Illusion meaning what I have just specified, that you are imagining something to be true when it is not true.
Right.
In the sense it's not part of nature, it's just a construct of your thought.
Right.
And if you saw that, directly perceived that, it would dissolve.
Right.
Because it's just your construct, and if you don't approach it that way, it'll go away. Like a scientist, when his theories are disproved, they just disappear.
Right.
Right?
Great. Right. You raised a very good point, and it brings up some very interesting recent work in my field, cognitive neuroscience, on why did we evolve the ability to have logic and reason. And Dan Sperber and Hugo Mercier have published a book recently on this, and it's, there's the normal debate, but I think it's an interesting idea. They say that we did not evolve logic and reason as tools to perceive the truth or to pursue the truth. Instead, we evolved logic and reason as tools of social persuasion. We're a social species. We need to work together. I can't bring down that woolly mammoth by myself. I need to coordinate with others. We need to figure out how we're going to do that. And so I need to convince you that I've got a good idea about how to do it. So I need to give you reasons to follow me, why I'm trustworthy and so forth. So we evolved logic and reason as a tool of social persuasion, not as a tool of the pursuit of truth. And if you take that point of view, it explains a lot of interesting features about the strengths and weaknesses of our ability at logic and reason. One of the weaknesses is we have what's called a confirmation bias. We are always looking for data and facts that will support what we already believe. When, from a logical point of view, if you want to make progress, you really want to evolve toward better beliefs as quickly as possible, you should be looking as quickly as possible for anything that would show you where you're wrong. But that's not what we do. And so we get social situations now where that's a problem. So we're always, and this is why we get into groups that have divisions and hold to their own beliefs. Once you have a group, and everybody has, a common set of beliefs, you can get what's called groupthink. You use your substantial logic and reasoning abilities to prove what you already know to be true, and to get information that substantiates what you already know to be true. So this gets at what you're talking. You can get into a vicious cycle of groupthink and be stuck for thousands of years. One positive thing that this shows about reason is when are our logical and reasoning abilities at their best? It's when we're in discussions. That's where the tool evolved. That's the field in which it evolved. That's the right playing field. So you'll notice that your ideas and your arguments come much more quickly when you're in a social situation like this, and the rebuttals come to you. When you're by yourself, it's a little bit harder to do the logical reasoning. It just comes natural. Why? Because this is the field in which it evolved. It's in social persuasion. So this does then lead to an interesting, important thing about science and spirituality. Why does science have the successes that it has? Scientists are just people. We are as just dogmatic as anybody else. We have the tendencies to groupthink like anybody else. We have confirmation biases just like anybody. There's nothing special about scientists. So why does science work so well? It's because we hit on an unusual social institution. In science, we demand that the hard-nosed, dogmatic, biased scientist must at least tell us with mathematical precision what her ideas are and what experiment we could do to test that. And so what we have in science is the requirement for mathematically explicit theories with explicit instructions about how to test them. And what we then do is we have 2 or 3 dogmatic scientists go head to head, each with their own confirmation bias towards their own theories, but definitely trying to take down the theories of the other. And because you're not trying to take down your own theory, you're trying to take down the other guy's theory, it works. Science takes this foible of human logic and reason and sets up a social institution that gives us the phoenix of science. It's because science has somehow engaged properly with and manages to counter this downside of human logic and reason. We can still have scientists who are all dogmatic, have confirmation bias, but because you have to be precise and we have to have experiments that can be tested, and that we then have this possibility. I would love to see a rapprochement in the near future between science and spirituality. Both have a piece of the puzzle. Spiritual traditions have long ago let go of physicalism. Scientists have not yet caught up. So spiritual traditions are, I think, ahead on that. On the other hand, spiritual traditions have groupthink. They'll have the same set of ideas for thousands of years. There's this document, it's the truth, and we use our logic and reason to support that truth. What spiritual traditions need to do is to be open to the possibility and that everything we've been taught and everything that we believe could be false. That's the scientific attitude. Everything that I've been taught in science could be false. Now, that's not an excuse not to study it. As a scientist, it's not saying, yeah, I don't believe in general relativity. Have you studied it? No, I don't need to. I don't believe in it. That's not an excuse for that. We have to study these things, take them very, very seriously, really study them so that we can intelligently break them. That's the goal in science, is to really master our current theories so that we can break them. And that's the attitude that I like to have in spiritual traditions. We have our set of beliefs, and that's fine. Don't hold them too tight. Try to figure out how you can break them. And letting go of the because otherwise we will just spin in the same circles forever. How can we make progress on spiritual issues if we're absolutely sure that we're right? Why not say I could be wrong about everything? And maybe that other spiritual tradition has an insight that I don't have. Or maybe all of our traditions are missing critical insights. Can we turn it into an experimental spirituality where we start to actually make testable hypotheses? So I would like to go there. Science and spirituality have something to contribute to each other.
Hi. Let's see. I'm not sure if I'll phrase this correctly, but it was something you talked about early on. I think you said that natural selection, natural selection favors a perception that is not true over the truth, over a perception that is true. And I think you said organisms that perceive things that are untrue are selected for above organisms that don't. What would be those organisms? And I have a follow-up question or a second question also.
Right. So when I'm doing that kind of work, I'm not thinking about the consciousness stuff at all. I'm just simply now taking evolution by natural selection on its own terms. And I'm using the assumptions of the evolutionary biologists and the evolutionary game theorists, right? So I'm saying I'm going to take your scientific theory and I'm going to study that theory and its implications. So in that theory, they postulate that there are organisms, but when you go to evolutionary game theory, what you do is you trade off organisms for something called strategies. So you can have players. The real thing that happens in evolutionary game theory is you're looking at different strategies that compete. So there's a strategy of seeing the truth versus a strategy of seeing part of the truth and partly fitness, and a strategy. So then you can ask how many players in these games adopt different strategies. You can sort of abstract away from organisms. But we do talk also, if we want to talk about, like specific animals, we can talk about specific organisms as well.
I thought organisms was your term that you used when you said that.
Yeah, because I was sort of adopting the terminology that's used in that field.
Sure.
So they assume organisms, so for sake of argument, I assume them.
I'm just thinking, we're talking about people and decisions we make.
Right.
If one perceives the truth, big concept, wouldn't one understand all the different options that another person could make? And therefore, wouldn't natural selection favor that way?
Yeah, there are selection pressures for us to understand others and their strategies. And so, the games that I studied were these simple foraging games. And then the new result that I've got has to do with actually the structure of fitness payoff functions themselves. It turns out, so I'll tell you why. I'll tell you why perceptions can't be vertical. This is the real reason why. If you look at a payoff function, it's a mapping from the world into a set of payoff values, like from small payoff, which means bad, to high payoff, which means good. Suppose there's a structure in the world. So the world has a set of states. It's got n states, 1 through n. Suppose that the world has a structure, like a total order, that the states 1 through n are ordered. 1 is less than 2, less than 3 in the world. Suppose that it has that structure. We can count, suppose there are m possible payoff values, 1 through m. We can count the total number of payoff functions. It turns out it's m raised to the n power, total payoff functions. We can ask how many of those payoff functions would preserve the structure in the world, such that if state 1 is less than state 2 in the world, then the fitness of state 1 is less than the fitness of state 2 in the world. So we call them, mathematics we call them homomorphism. We can ask how, for any structure in the world, it could be a total order, a topology, a metric, a cyclic group, we can ask for every structure in the world, how many of the payoff functions are homomorphisms of that structure? And it turns out the answer is the fraction is 0. As we let the number of states in the world and the number of states in payoffs, we let that number go to infinity, the ratio of the payoff functions that preserve structure in the world to the total number of payoff functions goes precisely to 0. That means, so here's the bottom line. the probability that a payoff function in evolution even has the information about world structure is 0. Evolution is tuning us to the payoff functions. If those payoff functions cannot have structures of the world encoded in them, then we could never be tuned to the structure in the world. That's why we don't see the truth. So it's independent of, so it's really, I don't need organisms, anything like that. It's the mathematics of payoff functions. So that's real inside baseball. I didn't want to go into it, but that's the bottom line is payoff functions almost surely never have information about the structure of the world. We're tuned to payoff functions, therefore our perceptions almost surely never have information about the structure of the world. It's that simple.
I had 2 questions, one from the stream and one from myself.
Yes.
Which latches on a little bit to what Batik was asking you, why you use the word consciousness. And because your first response was, well, I want to describe the heart problem. And the heart problem is had the taste of chocolate, or I don't know what the other one was you said. But then you could equally, I wonder why you didn't call it qualia instead of consciousness. And right. Because that seems to be the common word for that. So
Sure.
Yeah.
Good question. So the question is, why don't I use the word qualia when I'm talking about conscious experiences? And part of the reason why is that qualia has become a technical term in our field that has all sorts of baggage. Qualia are ineffable, presumably. They have all these different properties. And so if in the philosophy of mind and cognitive neuroscientists who are studying these kinds of issues, if you use the word qualia, that is a flag saying I have a specific set of ideas about conscious experiences. And there's a huge debate about the ineffability and so can they be described. And I don't want to get into all of that baggage. So I explicitly don't use the word qualia, not because I don't believe in conscious experiences, but I don't believe in carrying the baggage around and having people shoot at me for things I'm not saying. So, I mean, I get enough flack anyway, so I didn't want the extra flack from the word qualia, right?
But you chose out of 2, consciousness didn't describe it also completely, and qualia didn't describe, so you had to just...
I just use conscious experiences.
Yeah, okay.
And then I say what I mean, like taste of chocolate and so forth. That way I bring the minimal baggage to the whole thing. And then when I put down the theory of conscious agents and say all I'm saying is that these things are measurable spaces, I'm saying exactly what I'm assuming about consciousness, so that I don't have to deal with baggage that I'm not saying.
Good, and then from the stream, a woman called Alexandra Latrop. Robert perhaps put it well, I don't know who Robert is, but that might be in the previous part of the stream. Put it well, are dreaming ayahuasca, endocrines, and as he said, meditation, some removal of conflict in these experiences, or provide for a closer insight into deeper consciousness. Also, how would that be tested scientifically? Which is maybe latching on to question.
Right. So I'm not an expert in the effects of drugs on the brain and so forth, but I can say just a little bit. It does seem that there is evidence that drugs properly used can actually help us, number one, lose our addiction to our current interface. As we begin to realize that there are other forms of experience that are utterly different from the normal space-time objects experience that we have, it loosens the grip of this headset on us. And I think that can be useful. I haven't done it. I'm already out there anyway. Maybe I could make more progress more quickly if I. But there is some evidence that if you think about an interface. Now I'll forget consciousness for a moment and just think about it in evolutionary terms. This interface has an adaptive solution to certain life and death problems. It has its strengths and weaknesses. Sometimes our interface really does get in the way of us being healthy. Like the jewel beetle, right? The jewel beetle, it's got a useful interface, and most of the time it's useful, but if there's beer bottles out there in the desert, you're going to die because your interface has screwed you up. It was perfectly... So there's no reason why our interface doesn't have its own beer bottle problems, right? But they're different. And So I could imagine that the proper microdosing of LSD and ketamine and things like that could help certain people in certain circumstances to loosen up problems in their interface. You know, it seems to me far from a precise science. It's going to be exploratory, and it'll be a hard time before we actually can get mathematically precise theories of this, but I think it's worth exploring under careful, very, very careful conditions. I do know of stories of that are just, they're not scientific stories, but there are stories of people who've been helped. One young man who had stuttering problems, I think took ketamine and saw the stuttering as a rock or something that was in his way, and he realized, oh, I can just walk around that rock. And after that, after he came out of the experience, he never stuttered again. I mean, that kind of thing is just, you know, it's just a story, it's not scientific data, but you do have to start somewhere, and it makes me think that there could be possibilities about using these drugs very, very carefully to play with our interface. And eventually, as we really understand our interface, we may be able to more systematically help retool the interface. In fact, eventually, what would be really nice is we understand the relationship between our DNA and differences that people have in their interface. And there's just this brand new technology. It's called base editing. There's a TED Talk that just came out this month. You might, if you look it up, the TED Talk on base editing, they can go in and do point mutations, letter by letter now in the DNA, anywhere they want. So eventually we should be able, once we understand how the DNA is related to different problems on our interface, we could do changes, that maybe point mutation changes that get rid of certain blocks in our interface. That would be fabulous.
Okay, who wants the last question? Karen.
One thing that came up yesterday with Corey that I want to tie into what you're saying today is this question of, once you see the limits of knowledge, what is its effect on the unknowable? Or what is your contact with it, if we could put it that way? So when you say that the interface, the headset, the fitness, all those pieces look like the known,
Right.
and it points to an avoidance of truth. So could you tie those pieces together for me?
Well, there's a couple things that I think we can hope to have happen. Once you have a scientific theory, it gives you new tools to interact with reality, right? So, because of quantum theory, we have all of our modern technology, your cell phone and so forth. All these amazing things are the results of the conceptual advances we made in quantum mechanics. And we can ask, as we let go of physicalism, if in fact physicalism is false, then, and we start to, as scientists, begin to explore this realm of conscious agents, assuming that consciousness is fundamental, and that there is, we should start to get new tools that will allow us new technologies. And so we will be able to find new ways to interact with what hitherto has been unknown. This infinite realm of conscious agents. Most of us don't even believe it exists, much less interact with it. What's going to happen, if this is correct, is that we're going to start to develop tools that allow us to open up new portals, as I mentioned in the AI stuff, open up new portals into it. So there's going to be promise and peril in this. Every time that we get a new technology, we can make nuclear power and we can make nuclear bombs. And this, if this is right, this is going to open up the greatest power we've ever seen. We're now tapping into truth in a way we've never tapped into it before, and so it's going to be quite powerful. what might happen there. I'll say this, it will also help us reframe certain problems that we're solving right now. For example, the search for extraterrestrial intelligence. Where are we looking for the extraterrestrial intelligences? We're looking in space and time. We're assuming that whatever those intelligences are, they're somewhere inside space and time. Space-time is just your data structure. It's your visualization tool. There's no reason to expect that your visualization tool evolved to show you those. So if we don't find SETIs in space and time, extraterrestrial, so SETI is the search for extraterrestrial intelligence. If we don't find them in space and time, that doesn't mean that they're not there. We're looking in the wrong place. In some sense, they could be right here. But in fact, if conscious realism is true, they are right here. They're all around us. Our visualization tool just doesn't let us see them. So the search for extraterrestrial intelligence may be the same as the search for how to make AIs that are conscious. It's opening up new portals within our interface. That's the right way to do the search for extraterrestrial intelligence. So you can see that once we have this new framework, it gives us a whole new way of trying to interact with the unknown. We had made fundamental assumptions about where the unknown must live. It must live inside our space-time interface. Well, that might be drop-dead stupid and standing in the way of real progress. So we may have to rethink entirely how we do the search for extraterrestrial intelligence. So it really does have profound implications for how we're going to deal with what is for us now the unknown. Yeah. Okay.
We'll meet again this afternoon at 2:30.
Very good. Thank you. Thank you very much.